I like this class.
Which one?
I would take it, but I came in with enough
Oh, did you
time.
decide on that one?
Alright, so in this we left off this yesterday talking about motion in 2 dimensions.
What was that?
So in there, it's talking about this motion, we talked about how you break different things down, talk about different situations. So here at the starting point, highest point, and the end point, and the key here that we talked about, that end point is whenever you reach that end point there, you need to be mindful of whether it's hitting the ground or if it's still got motion going on. So, little things to keep in mind there. Majority of the time you'll find that end point to be 0, but we shall see. So anyway, moving from here. In 1 second. Right now, I'm still just working with your thought process. Still just want to work with your mind.
I'm not complaining about it.
Alright, so let's say in terms of motion, okay? In terms of force.
Well, I mean,
Thought thing, yeah. So in terms of force. If an object is at equilibrium, what are the forces? On it.
what are force?
Yep.
I mean, what is the force?
What are forces on it?
Oh.
He had that little S in real fast.
You gotta remember, I'm doing this out of my head.
Or do you mean what
I
force
still
is
remember
on it?
whenever you wrote coma instead of comma, so.
Do you mean
No
what
purpose.
forces are on it?
Yeah, what's going on forces wise? There's a key to this to figure this out. Here's the key. It's at equilibrium, which means it's not moving around.
Static.
Did you say you had a drop?
What?
Talk to me about the net force and the x direction. What would the net force and the x direction be equal to?
0.
0. And what would the net force in the y direction be equal to?
Is that also 0?
0. Ultimately leaves us with the net force equal to
0.
What'd you say?
0.
Just looks like
Just net force in general?
Just net force.
I know it's
Everything's canceling everything out. See, the fun thing with this is I start giving you scenarios and situations, and I tell you, look at this scenario situation, apply a force, and tell me what degree that force is at to determine, to make that system at equilibrium.
0.
So everything's got to be equal to 0.
You posted a video yesterday, didn't
Yes.
you? Is that like going over?
That's what we did yesterday in class. I did that because Taylor was not here, even though Taylor was here. It's quite glad.
Yeah.
What, you doing something about that?
Oh,
Oh, just wait.
He sat in his
Yeah, he sat in your seat and then he started like trying to talk like you, but it wasn't like you.
Well, he got his wisdom teeth removed, and he said he wasn't high. But he
Jordan Sampson, please report to class. Jordan Sampson.
I screenshot one of them.
Let's see that.
And then he like posted on our AP government group page, "Hey guys, I'm good.
It's lonely,
The drugs didn't work on me that much, so I'm bummed." I said, "You are definitely
I want to see it.
Yeah.
It's taken effect on me and Savannah. We was in STEM class today, and these formulas she's coming over has A in them, and I went to solve for
Acceleration?
Yes.
What's wrong with that?
From here, ladies and
Ruby
gentlemen,
is definitely high.
we start.
No. That is not.
So that's the notes for second dimension.
Oh yeah.
Okay, I'm done.
Wow.
All right. So in this, I'll give you a second to get that wrote down. Yeah, it's like today and tomorrow we'll be doing videos because Dylan asked me to do videos. Or should I say Taylor? I'm confused.
She'll be able to come back. We are tomorrow. I just had mine out Friday. And I was good.
You tell me what here. And it doesn't even matter. Well, tomorrow the cheerleaders are doing their routine, so it doesn't even matter.
Because they're going to regionals.
What if like volleyball teams and like basketball teams did that?
Like a showcase.
Yeah, like a little showcase.
Look at our skills.
Look at our skills.
Leslie, did you see the warm-ups they're wanting? The
Yes.
sleeveless with the hood?
Yes.
Everyone loves them and I hate them.
I think we look sick.
Darren said if we don't agree, he's buying them from Herbie. And I was like, please.
From where?
Herbie again. Because,
Oh.
yeah, the long sleeve.
God
t-shirt.
love his heart.
He's like, I don't want you guys to disagree, so I'll make the decision.
I think if we came out with our hoods on, I think
No.
these teams would
Like,
like.
Could you imagine
I'd
a
be
girls
scared.
basketball team full of 5'3", 120-pound teenagers?
No, but you gotta admit,
Came out in
Morgan
sleeveless
with
hoodies.
braided, with braided.
Just because Michaela will look baller doesn't mean
and Leslie and Hannah, they would look.
If y'all all were like,
I would be very
Y'all know
intimidated.
braids.
Like the
Team
not even the
braids.
like the braids that you do like on the
Really
sides.
tell this.
cornrow braids.
No, like the cornrow stuff.
I would be extremely intimidated if a team ran
Like
out
where it
like
goes
that
in
on
like
me.
one.
Why
I
don't
feel
you
like Mom and East will bully us. They'll be like, did you guys leave your sleeves at home?
We're gonna make fun of your hoods.
I'd look at him and be like, no, my muscles busted through them.
All right. So number 62.
I'm uncomfortable. Okay, so
I'd be like, look at my whole 5 pounds. I'll be looking.
wow, I'm just
All right, number 62 says the force is acting on the ring in figure 22. What is the net force acting on the ring?
Hold on.
Hey!
I'm not there yet. 0.
Could
Look
someone
at
go
this.
down?
No, it's not zero.
slow down, bro.
We get to solve this. Now, I highly do recommend getting calculators. I also highly
Can someone
recommend
just go
this.
get them on a packet?
Guys, this needs to be the golden rule in this class whenever you come in here. Because I reset these calculators for my chemistry kids whenever they take quizzes, and it automatically jumps to radians. You need to check the mode to make sure you're in the correct mode.
What page are you on?
144.
So we should not be in radians.
Should not be in radians.
I'm gonna take one.
I don't have to keep going back and forth.
That should be regular, right?
I'm just gonna buy a whole nother calculator.
Are we in degree or radian?
I already have one.
We are going to be in Right now, for what we're doing, we're sticking in degrees. Okay?
Alright, so 60.
Wait, I gotta write my name down.
62.
Is that wrong?
Does anybody else raise our acting on the ring?
Not me.
What's the net
Because I can't remember.
Alright, so in this,
So we're solving for net force.
you're solving for the net force. Now, in this, you need to keep some things in mind here. And I'm going to try and just like quickly draw
Go to mode.
what we have going on here.
Go down.
You don't have to. I'm doing it for the video.
Is that a perpendicular?
If you need to know how to do this, because this is the case, like if I reset the calculator,
No, there's a mark on it.
I can get it off. So it's reset now. So let me see if I can darken it.
Is that supposed to be like a perpendicular line, like a straight line?
Yes,
Oh, it's not that perpendicular.
I wasn't sure.
it looks horrible.
It's okay.
Okay, A for effort. This is an art class.
Alright, so on this, if you need to check and make sure that you're not in radians, okay, the dead giveaway is up here at the top. It tells everything. So right here where it says radians, I know I'm in radians. I need to go to mode, which is next to the second button. Hit mode. Go down to where it highlights the word radian. Scroll over to degree, hit enter, and watch the change at the top. I'm 9 degrees, so hit second and mode, which quits. So now I'm back to degree. And now in this, here comes the fun part. Man, I've been waiting for this. Woo!
Oh God.
That's scary.
So in this, we have a vector of 400 newtons.
Do you think it would be easier for us if we drew that?
I'm just gonna draw
Could be.
it.
I'm drawing, draw it just in case.
At 50 degrees. And then we have a second one. This is going to be hard.
Not drawing to scale.
That is 500 newtons. This one is at 40 degrees. It probably will help you to do it, yes.
I
Yeah.
went to the dollar store and I bought colored pen.
Oh, Mr. Hall, when are you gonna be putting in our handbook?
Here's. Yes.
Yours mine.
Need a custodian in the office, please. And a reminder that football does have film directly after school. Go to Mr. Halsey's room.
Listen, if I have to watch the movie, I would probably show myself.
But I'd rather go down and practice.
Do you get to watch them too?
We had before in basketball,
If it's a big game.
like Tommy games.
We may do it for like
How many did you bring, Leslie?
30.
30 minutes. Oh yeah, I still have stuff I need to bring in, but I keep forgetting it now. So it's even
Alright, so in this, here's the problem. Okay, now in terms of this, I'm still going to keep this as X and the Y, and I'm just keeping everything the same. It's simple in these things if you just keep them the same to where everything like is normal. So over here is positive X, over here is negative, up here is positive Y. Down here would be negative, we have nothing going down, so it doesn't matter. So in this, we've got problems, people. You can't solve this with these the way they are.
So you have to draw a line down.
Break the resultant vectors into
X and Y.
component vectors. So in this case, I'll figure it out later.
Your other one is 50-degree angle.
So if I got one of those trig formulas, then I would be able to solve this.
Yeah, like we're set. We can solve for this thing just as it is. You just have to build a triangle out of it. So like over here, have the force in the y direction. We're over here with force in the y direction. And then we're gonna need green and pink it is. So then here, we have the force in the x direction. Over here, we have the force in the x direction. Now here's the key in this. Think about this. The force in the x direction over here, is it going in the positive or negative? Positive. What about over here, the force in the x direction? Positive, negative. So this will be a negative force. In terms of my y's, will they be positive or negative?
Positive.
Both will be positive. So in this, we just need to solve for some information now. I'm going to solve this triangle first.
Which one?
The purple. So purple triangle first. So in this, I'm trying to find force y. Okay, so in this I have the sine, which is opposite over hypotenuse. I really want to jump. Is it okay if I try? No.
No, let's not do that.
Just hold on and let me figure out which colors you have.
Chloe's still probably I think. It's those videos and it's like the girls that are the girls I guess.
Don't even start with me.
Sun, orders, equals. I'm reading what it says, Chloe.
Wouldn't it be like the sine of 40? Would be the force of water with 500.
A pterodactyl.
What is it?
I say.
Let's do 500 times the sine of 40. Hey, if I haven't mentioned, by the way, make sure you're in degrees. Because that's like crucially important. Put that in there and I get 700.
Now might I ask why you divided?
Yeah, why did you divide?
What?
Ah, snap! I said the wrong thing. 'Cause I'm a man and I can make mistakes, that's why.
Hey now.
Where's my whiteout?
Be upset.
I let a kid borrow my whiteout now.
Where's my wife?
My Because like wife? I'm a man and I can make mistakes. Where's my wife? I literally I thought was that like, was
I thought that was.
So where's
That
the
was not what I said. I want to make sure I'm clear on
For
that.
clarification, Mary.
Mary don't watch these.
I have a white. Wait, never mind.
Are we sure?
I'm positive. Trust me, my wife is not interested at all in teaching.
If she
If
had
you
watched
watched
the
the
wrong
first
answer.
video, do you think you still would have gotten
Yeah, because I divided. That was from division.
Why is it the force of law divided by fucking
Opposite. Sine is opposite over hypotenuse.
Oh,
So there's the opposite, there's the hypotenuse.
Need a custodian in the office, please.
already in place of it.
Can you slide it over to?
Oh, I was like, that fraction
Okay.
How's that look?
Yes.
Much better. 3, 2, 1. Freedom.
Alright, so in this, okay, and guys, I'm telling you, you better make sure you can solve these. Don't just look and say, oh, I passed trick, I know what I'm doing, yeah. You need to be able to think about this too. Alright, so let's do the force in the x direction, which is cosine of 40 degrees, which equals f of x,
Oh, we're changing colors.
500 newtons.
So which one is this one? Negative f of x.
I just got that negative there because it's got to be a negative.
Okay, I gotta
So our number is going to be negative.
Yeah, this has to be a negative because it's going in the negative direction. You need to think about that. So in this case, move it around, 500 newtons times, not divide, Kevin.
He's talking in third person.
Oh, please don't. She's the please don't. Hey, were you ever have to do commentary whenever we wouldn't get along during basketball?
Yes, I do. I still do that to this day.
Yes,
So you had to put negative. What do you mean commentary?
I will be dribbling down the court,
yes.
like Taylor Brown makes a pass to Leslie Daly, and she shoots the three. I still do that.
It was so bad. We had to do it.
Okay. Before Savannah jumps down the throat. So there's the number we get, 383.0222 newtons, and it's got to be a negative. Why? Because that force is going in the negative direction. That's why we wrote that negative there.
Now do we do the other side?
Yes, we did. This is all you have to do.
Well, yeah, pretty much.
So later.
But without putting that in, we're surprises
Thrown at us.
It's gonna happen anyway.
Your f of x in that equation that you've got above your answer, it's supposed to be negative, right? You didn't just, do you get what I'm trying to say?
Yes, this is why, okay, whenever you solve for it, okay, when you solve for a triangle, triangles like a length. So can you get a negative length? No. So in this, you have to be able to think. That value, that number, is the magnitude for that force. But then I throw that negative in there because of the direction. It's going in the negative direction. So let's say I got an object here that has these forces being applied on it, and we want to know what the net force of that is. Like for some reason, I love to create problems and say, what is the net force happening on this Cheerio that's being pulled by these strings?
What is net force? What do you have to add all those together?
Why is this
You
stuff
will,
together?
but this, you can only add y and x components. That's why we're having to break this apart into y and x components. Because then what's going to happen is we're going to get the x component here, we're going to get the y component here, add them together, and then from those components we can put them together to find ourselves the resultant vector of the net force.
I swear, if this answer was mine.
So in this, moving on, we are now going to do the
If
blue
the answer
triangle.
is 900 newtons,
Just
I'm
walk
gonna be mad.
Pretty sure it's not 900 newtons. Could be, but I'm going to say it. Don't think it is.
It was me.
I was like, because he said you can't add the result vectors.
Oh, you're not
together.
ahead.
All
Alright, so in this, starting with the force of y again. So, we'll work that. Force of y for the blue triangle will be the sine of 50 degrees is equal to f, oh man, f sub y divided by 400 newtons. So f sub y is equal to, you don't have to have the different color pens, I'm just doing it so you guys can.
I know, I was just saying that's how I'm like establishing the difference between the two triangles and everything.
She's better because me and Chloe.
You get what
I'm joking on this.
What?
I don't know where you are. Newtons.
I get 306.4178 newtons. It's in the positive direction, so it's positive. Then from there, find f sub x, which will be equal to the cosine of 50 degrees. What? Okay.
I'm just trying to write. I feel like I understand
I had to switch colors.
These right here are simplistic problems. These are not hard. Whenever you guys start thinking about the forces and things that's being, whenever you have to take a word problem and break it apart, that's when things get difficult.
But the basics of this little lesson here,
But didn't you say
it's all
something
going to
about
be
this?
this, right?
Pretty much.
I thought you guys did a hard one.
I love this.
That you've done yet? Yeah. This is not going to be the hardest.
I love that.
I promise you. Give us by December, y'all be wanting to come back to this.
Okay. Whenever you get those answers, do you add all four of them together, or do you add one?
No. X components add with X components. Y components add with Y components.
I was gonna say that.
Yep.
So you get two answers,
Because those are components.
and then you add those two together.
You don't add them.
Well, I know X and X goes together and Y and Y to go together. After you get those answers, do you add those together?
Let me get that. It's not as simple as adding. You're going to use Pythagorean here. So f of x divided by, I'll make sure I do it 400.
Well, then do you add the result vectors or
100 times cosine 50.
you add the X's and you add the Y's, and you add the resultant vectors together and do the Pythagorean theorem?
You're requiring me to think right now. So I'm trying to do math. This is hard.
257.1150 newtons. Zero newtons.
This will be positive because it's in the positive direction.
Yay. Now how do we get that force?
I know you add X and X, and then Y and Y, but that's all I know.
Yeah, is this how like, is this like really like how our problems are gonna be?
Some of them.
Because I like these.
The more simplistic ones.
They're simple. I love trig.
In Miss Archibald's words, let's get tricked up.
Let's get trig.
She says that.
She said
She
it
said
every day when we were in trig last year.
We'll start. Let's get physics up.
No, it doesn't have the same ring to it. You can't steal it.
Make up your own thing.
Yeah, we're being a copycat.
Oh, I wasn't saying he was being a copycat.
I was.
We're not.
Why does everybody be mean to me?
I wasn't trying to be mean. I was just like, you can make up something funny.
You could still say that for your chem class. You could say let's get chemmed up.
Y'all better noble gas me up.
I was defining physics today at lunch, and he said I wasn't. Just saying.
You weren't.
The force of the can from somewhere.
Am I a dependent student? Or what do you mean? I mean, you leave your parents. Okay.
Okay, I'm sorry. I didn't realize I was clicking that down.
It's actually not okay. Don't ever lie. Okay,
Was what it sounded like.
here's values I get. We solved for those values. Now in this, to get what we need, we got to add them together. So the net force in the y direction will be equal to 321.3938 newtons plus 306.4178 newtons.
Wait a minute. So you add the y's and add the x's, and then do your Pythagorean theorem that way and get your.
Yeah, but then there's also something else you gotta add to it.
Oh no.
You guys can love this.
It was so simple.
No, it is simple.
Oh, wait, never mind.
So that's y. And then we're looking at the net force in the x direction. Be equal to negative 383.0222 newtons plus 257.1150.
You won't get a negative.
Yeah. Y'all
Okay, Savannah, you calculated that.
Negative 125.9072.
She said,
Negative 125.
I'm over here freaking out at 3 people, so help me freak out.
You got negative 1.5.
9072.
That's what I get.
Newtons.
Okay.
Alright. Then you gotta
Pythagorean theorem.
Pythagorean theorem.
Like that one, your x. Your I know this. It's like I know like x would be the a and then y would be the b and then c would be your resultant vector.
It'll be, yeah.
Okay, wait, we're not good.
Slow y'all roll.
Yes, sir. Yes, sir.
I want to make sure I get everything correct.
Did we get it?
Did we say
You are, but there's a key to it also. You also have to think. All of this is in kind of like a circle. It can be 360 degrees. So not only do you have to give me that net force, but you also are going to have to give me an angle. Because if you don't give me an angle, then I can't tell.
an angle?
360 is a circle.
You guys, there's a reason that's negative. Y'all tell me when you're ready.
Okay,
I'm trying.
Listen.
Would you rather us ask questions later about it?
And fail.
No, I want you to ask questions now.
Here we go.
Thank you. That's what you said.
Now, can you tell me why we have to add it together and do all that things?
Because those two forces are acting on it. So, like in this case, so here you have these y components.
Yep.
It's kind of like this is going to be, let's say that for some reason we have a dog that is down in a well and we've connected a rope to this dog and we're trying to pull it up. This could be like the force that, you know, I'm applying on the rope, pulling the dog up, and this is the force that Dylan is applying to pull the dog up because I'm clearly stronger than Dylan.
Clearly.
So in this, okay, this is not like this force, my force by itself is not canceling his force out because we're both pulling in the same direction, so it's adding together.
So what are we finding? Just force?
You're trying to find the net force.
Why would we be able to find the net force if we just added those two x and y forces together? Like 627.8
Because
6.8.
you got to remember, they're vectors. Okay, what did we do to get to where we are? made triangles, broke them apart, worked from those components. Now from those components we have these right here are the components of the net force. But it's not so simple as just looking and saying, let's add them together. You got to build a triangle out of this. Because look, I'm going to start with my x. I go 125.0972.
Backwards.
Okay, I'm going to say I'm going to make it blue. Am I going to the left or right?
Left.
Left. So I start here, I go to the left. And I go to the left 125.9072. Remember, these are vectors. So with these being vectors, you have to add these together. So 672.8116 newtons.
Goes up.
But you don't go, you can go from here, but I'm going to do head to tail method. So I go to the tip, and I'm going up.
Because it's positive.
627.8116 newtons. Thus, we've made a right angle here. And with this, to find our net force,
And then do the Pythagorean theorem.
to give you the magnitude. So to find this, you're going to have to do the Pythagorean theorem. So in this case, I'm going to call this R.
Can you scoot that back up a little bit?
So R squared equals, let's call that Y. That's Y, and this is X. So X squared
640.3124.
Y squared. So R squared. So R is equal to the square root of.
I thought R.
125.9072 newtons. That's squared. Plus Y, which is 627.8116 newtons, and that's squared also.
What is it?
I have a quick question.
What's the question?
Why is it not negative?
Why is X not negative?
Yeah.
Because it's, in this case, I'm dealing with a magnitude. I didn't put negative there because it really doesn't matter.
Okay.
If I had a negative down here, is it going to factor in? It's squaring, so it don't factor. If it makes you feel better, Molly, put the negative, because you're not wrong. So, I'm going to square root.
I got 640.3124.
So what's gonna happen when our starting triangle, instead of them giving us 500 newtons, they give me a different, like unit? And we're looking for force. Is that ever gonna happen? Or can we not solve for
No,
it?
you'll have a way. You'll have to.
Okay.
So there's that. I now have solved and found R.
It's okay, the 627 number
And now there's a problem here.
plus the 125 number squared.
Why is there a problem?
Because you're not just finished here.
We should have gotten it.
We need to find that force.
You got the net force, you have the magnitude of it, but now also part of force. Force is vectors, so not only do we have magnitude of force, we also have the direction of the force. So we have to find that direction. Whenever you're doing that, here's what you're ultimately going to be looking for. An angle. Now here's the key. It's got to come from the positive x axis.
I don't know how happened. I wasn't literally wasn't looking. Just like
So we're trying to find theta.
there.
You have to come up with a way of finding theta. Don't think too hard
More than
about it.
90.
What's the way that you can
That's
find
90 degrees. Wait.
Well,
Well,
yeah, well, you know that the current is.
you can use your,
So then why?
like there's an equation to use the length of the sides to find the angle.
Yeah.
Yeah, side angle,
But
side.
that angle's not part of that.
Well, you don't have to have part of that. You can find,
You just have to
that's
find
90
that.
degrees, and then the other side is 90 degrees, so one part's gonna, like, it's gonna be,
Is it
Yeah.
140
Y'all-
90
degrees?
degrees.
well, the y is perpendicular to the x-axis.
Okay.
So therefore, no,
on the other side.
No,
You know,
like your
we know part of
y-axis,
theta
that
is
y,
90.
yeah, the right part of
So we
theta
know
is
it's more
90.
than 90.
So all we have to find is the other fractional part.
Is it 140 degrees?
Which is, what's the term? What's that?
Side angle.
If you can find the angle, if you can find that angle,
Right
then
there.
then you can find the little angle.
Yeah.
Because that angle plus the little angle is going to equal 90.
Then you
Because
just add the little angle to
beta
90.
plus theta equals 180,
Yeah.
called supplementary angles.
Yeah,
So you guys are on board. It just,
we explained it differently.
yeah. I thought y'all were wanting to flip this and put this triangle up here and then say we're going to find this and work that way. I'm like, oh my gosh, what are y'all doing? All right, so in this case, we got to find beta. In this case, simplest thing you possibly can do. I like to use as much information as given to me as possible. In this case, everything we solved for, so it really doesn't matter. Just so we make sure that everybody's clear and good with their normal, everyday trig functions.
Need to see Jessica
I
Brown,
will use tan.
Kaylee Adair, Evan Bailey in the office.
So tan, and this is a beta. We're trying to find beta. Is equal to opposite, so y over adjacent x. In this case, to find beta, it's going to be equal to the inverse tangent of y divided by x.
Volleyball players, please stop by and see Miss Banther in room 1025 before you leave.
Well, that,
So the inverse tangent, y is 627.8116 newtons divided by x, which is 125.9072 newtons. Newtons cancel, which is good. We're trying to find an angle here. And we'll go into the inverse. And
Come over to Benny's.
now how come here the negative doesn't matter? Because you're not squaring it, so shouldn't it be negative on the bottom?
I don't think it's gonna matter.
Okay, I was just gonna ask.
78 below.
I mean, can you have a negative angle?
Okay.
No. So we're looking at 78.65. This is why it doesn't matter here, is because it's the length of a triangle. 659 degrees. So now we have that. So now we can look and say that we're trying to find theta.
Use 180 minus beta. And then get it.
So beta plus theta, 180. Yeah. So then we're trying to find theta, so theta is 180 minus beta, which we calculated to be 180 minus 78.6598. I get 101.3402 degrees. So the ultimate answer here is net force is equal to 640.3124 newtons at 101.3402 degrees.
So that's the answer?
That is the answer.
So, like, we're going to do those at signs.
Where'd the 640? Okay.
That's the,
The apartment.
yeah. How y'all feel about that?
So like everything is great until I get up to like finding just in that. Like as far as like the simpler stuff.